Okay, so the next thing that we have here is exercise 10.3, which is reduce the following equations into slope-intercept form and find their slopes and the y-intercept. So the slope-intercept mode form is basically your equation is originally in the form ax plus by plus c is equal to 0. This is the general form of the equation of the line. Now the slope-intercept mode form is basically y is equal to mx plus c. That is the slope-intercept form. And this is your slope, and this is your y-intercept. Now in this, basically, we said that in the slope-intercept mode or form, basically your m is equal to negative a by b, and your c over here, which is lowercase c, is equal to negative c by b. But of course you don't really need to, it's useful to know these, but it's not really very necessary. Not crucial to know these, because you can always play a little bit with your equation and get it in any form that you want. So basically, for example, let's say that you have x plus 7y is equal to 0. If you want to write this in slope-intercept form, then you need to, basically you can write it as 7y is equal to negative x, and then divide by 7, you will get y is equal to negative 1/7 times x. And you can see that the intercept of the y-intercept is equal to 0 here. The y-intercept is equal to 0, and your slope is equal to negative 1/7. And when your y-intercept is equal to 0, that means that this line goes through the origin, and the slope of the line is negative 1/7. Negative 1/7, when the slope is negative, you will get a line like this. This is negative. When the slope is positive, you will get a line like this. Now, what this number tells you, the number itself, meaning 1/7, what this tells you is that for, basically, we said that m is equal to basically y2 minus y1 over x2 minus x1. That means that this is basically the numerator is change in y, and the denominator is change in x. And they also call this rise over run. That means that this is basically the change in along the horizontal axis, and the numerator is change along the vertical axis. So basically, then 1/7, what that tells you is that for every 7 units of horizontal change, for every 7 units of of horizontal change, you will have 1 unit of vertical change. And since the number is negative, that means that you will have 1 unit of vertical change in the negative direction, in the negative y direction, So what that means is that, suppose that you start from this point, and then for every 7 units of horizontal change, meaning that 1, 2, 3, 4, 5, 6, and 7, 1 unit of vertical change in negative direction. That means that you will end up over here. 1, 2, 3, 4, 5, 6, 7, and -1 over here. So that will be and so as a result, that will be the graph of the line, basically. That will be the graph of your line. So that much, if you understand about these lines, it's basically more than enough. Or if you have, let me see if I 10.3 y is equal to -1/7 x, -1/7 and 0. Okay. So the second line that we have is 6x plus 3y minus 5 is equal to 0. Now you can write this as basically 3y is equal to -6x plus 5, and then y is equal to -6 divided by 3x plus 5 divided by 3, and so your y is equal to -2x plus 5/3. So this form is the slope-intercept, intercept form of the equation of the line. And so your m, which is equal to -2, and your y-intercept is equal to 5/3. So that means that your y-intercept, the line goes through the, basically, if this is 1 2/3, let's say that this is 1 2/3, this is 5/3, this is 1 point on the graph of the function, or the line, and the slope is -2, that means that you would get, for -2 is the same thing as -2y1, that means that for 1 unit of horizontal change, you have -2 units of vertical change. So for 1 unit of horizontal change, you have -2 units of vertical change, meaning that you will end up somewhere over here, and that's going to be the graph of the line. So that is that. And number 2 is y is equal to -2x plus 5/3. Number 3 is y is equal to 0. Y is equal to 0. So this line is already in any sort of form that you might think of, because your b is equal to 0, your c is equal to 0. So it's just simply a horizontal line, meaning that it's just simply this line over here. So this is y is equal to 0. It becomes the x-axis itself. So this is y is equal to 0. And so this is the x-axis, this is the y-axis, and over here your slope is 0. Slope is equal to 0, and your y-intercept is equal to 0. and your y-intercept is equal to 0. So the next question that we have is reduce the following equations into intercept form and find their intercepts on the axis. So the intercept form is basically if you have your line in the form ax plus by plus c is equal to 0, the intercept form is going to be x over a, for example, plus y over b is equal to 1. This is the intercept form. And basically, if you go through the process that we went through, you will write your line in the form x over negative c by a plus y over negative c by b is equal to 1. That means that a is equal to negative c by a, and your b is equal to negative c by b. And your b is equal to negative c by b. So this becomes your basically x-intercept. This becomes your x-intercept, and this becomes your y-intercept. So now you need to basically write your equations basically in this form. Salam alaikum. Ahval shunshna. So for example, if you have this equation over here, 3x plus 2y minus 12 is equal to 0. If you have this equation over here, so then basically you need to write it as, for example, 3x plus 2y is equal to positive 12, and then if you divide by 6, you will get 3x divided by 6 plus 2y divided by 6 is equal to 12 divided by 6, and 3 divided by 6 is equal to basically 1/2. 2 divided by 6 is equal to 3. So then you have basically 2 divided by 6 is equal to 1/3, and 6 divided by 6 is equal to 2. And so you have basically x divided by 2 plus y divided by 3 is equal to 2. Now you want to make this a 1. Basically this has to be a 1 because your equation has to be in the form x divided by a plus y divided by b is equal to 1. So the coefficients of x and y are already 1, but you want to make this also 1, so you have to divide by 2. So you can write this as x divided by 4 plus y divided by 6 is equal to basically 2 divided by 2 is equal to 1. And so you can see that your x-intercept is equal to 4, and your y-intercept is equal to your y-intercept is equal to 6. So question number 2, x divided by 4 plus y divided by 6 is equal to 1, 4, and 6. So for example, this is the first one. The second one over here, we have another equation. For example, 4x plus minus 3y. 4x minus 3y is equal to 6. So if I divide by 12, for example, 4 times 3, I get 4x divided by 12 minus 3y divided by 12 is equal to 6 divided by 12. And so this is a 3 over here, this is a 4 over here, and this is a 2 over here. Now we get basically x divided by 3 minus y divided by 4 is equal to 1/2. Now you want to get a 1 over here, so you want to multiply by 2. So if you multiply by 2, you will get basically 2 times x thirds minus 2 times y divided by 4 is equal to basically 2 times 1/2. 2 times 1/2. Now this is 2/3 times x. This basically this part over here is 2/3 x. So if you want to write it as a denominator, you can write this as x divided by 3/2, meaning that the reciprocal of 2/3. So you can write this as x divided by 3/2 minus basically 2, and that you can cancel out. You will get y divided by 2 is equal to, these two will be cancelled out, you will get a 1, so that you will get a 1. So that means that your x-intercept is equal to 3/2, and your y-intercept is equal to 2. Actually, your y-intercept is not 2, but it is it must be actually -2, because you've got a negative sign over here. I think this becomes either let me see, if I write, for example, x plus, x plus y divided by, if I write x plus, for example, x plus y divided by -2 is equal to some number, for example 5, then I can write this as -1/2. I can write this as x plus -1/2 times y is equal to 5, and then I can write this as x, and of course this is the same thing as x minus 1/2 times y is equal to 5, and then again I can take this as x minus y divided by 2 is equal to 5. So that means that these two are actually the same things. So that means that your y-intercept here is actually -2, not 2, because you have a negative sign over here. And the reason why I'm saying this is that basically your intercept form of the equation is x divided by a plus y divided by b is equal to 1. Originally you have a positive sign over here. Since you got a negative sign over here, that means that this number over here has to be negative. So this becomes basically your y-intercept becomes -2. So let me check my answer, number 2. The second part is x divided by 3, x divided by 3/2 plus y divided by -2 is equal to 1, which is correct. And the way that I verified this was that I wanted to make sure whether these two statements, this statement over here is the same as this statement over here. And so I started with this one, and I somehow got to this statement, so that means that these two statements are actually identical. So the next question that we have is basically the third part of this question, which is 3y plus 2. 3y plus 2 is equal to 0. So as you can see here, your a is equal to 0. Your a is actually equal to 0. A is equal to 0. That means that in the intercept mode, you cannot actually write this in the intercept mode, because in the intercept mode, in the intercept form, you are actually dividing by a, and you couldn't do that if a is equal to 0, meaning that your equation is ax plus by plus c is equal to 0, and then you, through all of the process that you go through, you write this as x over negative c over a plus y over negative c over b is equal to 1. And as you can see here, you're dividing by a, which I suppose is not possible. But let's try to write this equation in basically in some other form. Let's see what we get. So over here, you would actually get some sort of basically horizontal line actually. So you wouldn't have any. You would have one intercept. You would have a y-intercept, but no x-intercept. Meaning that 3y, you can write it as negative 2, and then you can write y is equal to negative 2/3. And then you would get this line over here. Y is equal to negative 2/3 would be this line over here. You do have a y-intercept, but you don't have any x-intercepts here. So that's basically that. So the next question that we have is, we want to reduce these equations into normal form. And you know what normal form is, so let me make some space over here. 41. So the normal form is basically, if your equation is originally ax plus by plus c is equal to 0, and so you write your equation as x times cos omega plus y times sine omega is equal to p. And you know that basically p is the length of the, suppose that you have a line over here, and there is a perpendicular from the origin of the coordinate system. This length over here is p, and this angle over here is omega. And that's basically the normal form. Now, in this configuration of the equation of the line, basically we said that cos omega is equal to plus or minus a over the square root of a squared plus b squared, and sine omega is equal to plus or minus b over square root of a squared plus b squared. and P is equal to plus or minus basically C over square root of A squared plus B squared. So if you ever need to basically do some calculation, you can use these formulas as well. But now once we go through the process, I will tell you more about how you can actually convert your equations into normal mode. Okay, so now in case you want to convert any of these such equations into basically into normal form, which is basically this thing over here, which is called the normal form, what you can do, basically there are two things that you can do. Either you can why was I here? Okay, so now I had to basically do a couple of things. I mean, I did, for example, about this equation, there is an equation over here that we want to basically convert into normal form, which is x minus the square root of 3 times y plus 8 is equal to 0. Okay, and I did play with this a little bit, like half an hour even, and I was just talking and talking. And the interesting thing about these exercises is that you realize many little things, little but very important things and details that you need to understand about the very little things about mathematics. And that's basically the gist of mathematics. If you don't understand those little things, even if you understand the concepts really well, you will not be able to actually use the concept, because for example, let's say that you want to, for example, convert this equation into normal form, and then over here, as you know, since we are dealing with all of these angles, then of course you need to know all the little details about, for example, trigonometry. And then while you're solving the problem, you will run into some problem, and you will have to basically go back to your trigonometry if you have any problem and take care of the problem. So these are actually very valuable sources of finding your own shortcomings and finding your own typical mistakes, and you will be able to take care of them. So don't skip any exercises. Do as many exercises as you can, and of course then you can never, then nothing can go wrong as long as far as your mathematics is concerned. So now we said that basically basically in this equation, as you can see, my a is equal to basically 1, my b is equal to negative 3, negative square root of 3, and my c is equal to positive 8. So, and we said that basically cos of omega is equal to a over plus or minus a over square root of a squared plus b squared, and basically sine of omega is equal to plus or minus b over square root of a squared plus b squared, and your p is equal to basically plus or minus c over the square root of a squared plus b squared. So what that means is that when you can actually use these formulas to, for example, calculate cos omega, sine omega, and p, and put it in this equation, in basically in x times basically cos omega plus y times sine omega is equal to p. You can do that. And let me just, for this one example, let me do that and pay attention to the process, to what happens here, and then based on that you will know basically what to do the next time. So if I want to calculate, for example, cos omega here, it's going to be a, which is equal to 1, and that's plus or minus 1 over the square root of a squared plus b squared. So that's 1 squared plus negative square root of 3 whole squared, and that's equal to basically plus or minus 1 over, basically this is 1 and this is 3. Negative square root of 3 squared is equal to 3. 3 plus 1 is equal to 4. That's the square root of 4 is equal to 2. Plus or minus 2. So your cos omega is equal to plus or minus 1 over 2. Now your sine omega is equal to plus or minus b over the square root of a squared plus b squared, and that is equal to basically plus or minus b, which is equal to negative square root of 3 over the same thing, which was basically square root of 4, which is equal to 2. And you can forget about this negative sign because it will be taken care of by these two signs. So you can forget about this one. So you have sine omega is equal to plus or minus square root of 3 over 2. And then you have your p, which is equal to plus or minus c over the square root of a squared plus b squared, which becomes basically your c is equal to 8. So that becomes plus or minus 8 over 2, which is equal to plus or minus 4. So your p is equal to plus or minus 4. So now what you can do is that put these numbers over here, meaning that you can write basically, x times cos omega, and the way that you can choose the signs over here, I suppose there is no other way other than basically taking care of the sign, paying attention to what sort of sign there was here already before you started the process. So you can see that here you have a positive sign, you have a negative sign, positive sign. If you do it based on the signs that you already have, it will work. But I'm not really sure if that's the right way of doing it, but I'm pretty sure that I'm 100% sure that it will actually work if you do it this way. Meaning that you choose the sign that there is over here, and then based on that choose, for example, let's say that there is a positive over here, and this is the coefficient of x, and the coefficient of x is supposed to be cos omega. So cos omega is plus or minus 1 by 2, and it's supposed to be positive. So I choose positive 1 by 2 over here. So that's positive 1 by 2. And then for your y, you can see that you have a negative sign, and so you choose negative square root of 3 by 2. Negative square root of 3 by 2. And here you have a positive sign, so you choose basically positive 4 is equal to 0. Then you can write this as x times 1 by 2 plus y times negative square root of 3 by 2, and that is equal to negative 4. Okay, so here there is something important, and one thing that you can pay attention to right now is that you can see that the original equation that I had was x minus the square root of 3 times y, square root of 3 times y plus 8 is equal to 0. And now what I have done is that I have just divided the whole equation by 2, meaning that I take this equation and write it as 1/2 x minus the square root of 3 by 2y plus 8 divided by 2 is equal to 0, and that's basically what I have over here. If I move this one to the other side, I will get exactly this equation. And that's why basically in the previous example that we did, we just simply calculated the square root of a squared plus b squared, and then we divided the whole equation by this. And in this particular example, the square root of a squared plus b squared was equal to 2. And so if I had taken simply this 2 and divided my whole equation by that, then I would have gotten the answer that I already have over here. And you can see that, of course, the square root of a squared plus b squared is already in the denominator and of each of these numbers, and the numerator of each of these numbers is basically the coefficients of x and y and the constant itself, meaning that you're not really changing anything. You're taking the number that you have over here, whatever it is. For example, you have a 1 over here, you're taking that 1 and dividing it by square root of a squared plus b squared. In this case, you're taking this number, whatever that is, dividing it by the same number. Again, here you're taking this number, dividing it by the same number. So if you simply calculate this part over here and divide your whole equation by that, it's basically the same thing, and it will work for you. But now, since you know that basically this is your p, this number is p, and it's not supposed to be a negative number. So you want to take care of that. And of course, based on this, once you change this, your angles are going to change as well, meaning that in the way that I have written my equation right now, basically cos omega is right now equal to 1 by 2, and sine omega is equal to negative square root of 3 by 2. Now, basically you're looking for an angle whose cos value is 1 by 2, which is basically 60 degrees. But the sine of that angle has to be negative square root of 3 by 2, which is something like, for example, if you go for 60 degrees here, the cos of this angle is of course 1 by 2. But then the sine of this angle is going to be positive square root of 3 by 2. So you have to move to this quadrant, and when you move to this quadrant, then the cos becomes negative. So then you will lose this side of your trigonometric ratios, and then you need to move to the next one, meaning that you need to move over here, and then you will get basically this angle over here, which is basically 60 plus 180, which is equal to 240 degrees. 240 degrees, and then for this angle, your cos is negative and your sine is negative, which is still not the right one, not the right thing to go for. And then if you go for this angle over here, which is basically 300 degrees, which is 300 degrees, then your sine is negative. Your sine here is negative and your cos is positive. So you could choose this angle. But the problem is that this is actually not the right angle, and this angle is, what this angle is doing is actually, this angle does basically decide the slope of your line, meaning that if you have an angle of 300 degrees, And if suppose that, for example, let's take this as 4 units, 300 degrees is going to give you, for example, some angle like this, and 4 units over here, then that your line is going to be some line like this. But if suppose that, for example, your angle was 120 degrees, something like this, and then 4 units over here, then in that case you would get a line essentially with the same slope, but, well, having a completely different y-intercept and x-intercept, basically a completely different line. So this angle does decide the slope of your line, and the y-intercept of your line, the x-intercept of your line. You have to be careful about that. So in order to take care of that, what you need to do, of course, first you need to take care of this number that you have over here. And about this number, what you need to do is that basically you have to multiply your whole equation by a -1 so that this number becomes a positive number, because it's a distance. It's not supposed to be a negative number. So then you will get x times -1/2 plus y times positive square root of 3/2. Okay, so you can see that both of these did change, is equal to +4. Now your cos omega is equal to -1/2, and your sine omega is equal to square root of 3/2, which is, your cos is negative, your sine is positive. That means that you're in the second quadrant. You are in the second quadrant over here. So this is 60 degrees, let's say. So if you go another 30 and 30, another 60 degrees, you will get to this angle, which is equal to 120 degrees. And this angle has the same sine, basically the sine of 60 degrees is equal to square root of 3/2. The cos of 60 degrees is equal to 1/2. Now about 120 degrees, the sine of 120 degrees is equal to square root of 3/2, the same thing, but the cos of 120 degrees is equal to -1/2. -1/2, which is exactly what you're looking for. So then the angle that you choose is 120 degrees. So then you can write your equation as basically x times cos of 120 degrees plus y times sine of 120 degrees is equal to 4, and that is the equation of your line. That is the equation of your line. Okay? So, as you can see, there goes a lot into solving these problems, and of course, when there goes a lot into solving them, there you will learn, of course, a lot. But you need to have the patience to do them one by one and not skip any of these examples. These are valuable examples that you must do if you want to learn mathematics. That's basically the price that you have to pay. Okay, now I basically take a few minutes break, and we have a couple more equations here to solve. Okay, so the next question that we have is basically this question over here, which is actually an interesting problem. Meaning that the equation that you have is basically y minus 2 is equal to 0. And if you take 2 to the other side of the equation, you'll get y is equal to 2, and that there you will get this horizontal line as y is equal to 2. And of course you can see that the coefficient of x here the coefficient of x here is 0. So you can write this equation as, you can write it as 0 times x plus basically 1 times y is equal to 2. Now, of course, you already know that basically the normal line that you draw from the origin has a 90 makes a 90-degree angle with the positive direction of the x-axis. So then you have to go for all basically the two trigonometric ratios of 90 degrees, and you know that cos of basic 90 degrees is equal to 0. So you can write x times cos of 90 degrees, and sine of 90 degrees is equal to 1. So y times sine of 90 degrees is equal to 2, and that's basically the equation of your line. So x times cos of 90 degrees plus y times sine of 90 degrees is equal to 2. So you need to basically to actually pay attention to how, for example, you solve this kind of typical problem. And the next question that we have is x minus y is equal to 4. X minus y is equal to 4. So over here, as you can see, your basically your a is equal to 1, your b is equal to negative 1, and you can basically write this as 1 and negative 1. So you can write this as basically you can write cos of omega is equal to 1 and sine of omega is equal to negative 1. And sine of omega negative 1 is basically at 270 degrees. At 270 degrees. And then at that angle, well, this is basically a line. So if you write negative y is equal to negative x plus 4, negative y is equal to negative x plus 4, and y is equal to x minus 4. So this is going to be a line which has a y-intercept of negative 4 and basically a slope of 1. This is going to be a line like this, meaning that the angle that you have over here is most probably is definitely basically 270 plus 45. 270 plus 45, which is equal to 215 degrees. 215 degrees. 30. So 40. That's 300. That's 315 degrees. I'm sorry. 270 plus 45 is basically 300 and basically 315 degrees. But the problem is that sine of 315 degrees, of course, is not equal to negative 1, and the cos of omega would not be equal to 1. So what do we do here? So I suppose if I calculate basically if I calculate the square root of a squared plus b squared here, I would have basically the square root of, basically that would be the square root of 1 squared plus 1 squared, or basically negative 1 whole squared, and that would be equal to the square root of 1 plus 1, which is equal to the square root of 2. Now if I divide, both sides of this equation by let me write this way. If I divide basically 1 divided by square root of 2 times x minus 1 divided by square root of 2 times y is equal to 4 divided by square root of 2. And now you can say that cos of omega is equal to 1 over square root of 2, and sine of omega is equal to negative 1 over square root of 2, and that is basically if you have some angle whose cos is basically square root of 2 over 2 or 1 over square root of 2, and but the sine of that angle is negative, so it's either in the third quadrant or in the fourth quadrant. But since your cos is positive, you are in the fourth quadrant, of course, and that angle is of course the same angle that we got over there, 315 degrees. So because it's a multiple of 45 degrees, so you see this is basically 45, this is 2 times 45, this is 3 times 45, this is 4 times 45, over here you have 5 times 45, over here you have 6 times 45, which is 240 plus 270, and this is 7 times 45, and 7 times 45 is 280 plus 35, which is equal to 5, 11, 315, exactly the angle that we got in the beginning. But of course I was not aware of the square root of 2 and the whole story there. So that means that your omega is equal to 315 degrees, or in radians you can say basically 1, 2, 3, 4, 5, 6, 7 pi by 4. 7 pi by 4 you can say also. So then I can write this equation as basically cos of 315 degrees plus not minus but plus, because the sign is negative itself, so plus x times cos of 315 degrees plus y times sine of 315 degrees is equal to 4 over square root of 2 is equal to 4 over square root of 2. And of course you can rationalize this if you want to, but this must be the correct answer. So number 3, part 3 is x times cos of 315 degrees plus y times sine of 315 degrees is, they have written it as 2 times square root of 2, meaning that 5 over square root of 2 you can write it as basically 4 times square root of 2 over square root of 2 times square root of 2, and that is equal to basically 4 times square root of 2 over 2, and these you can simplify and you'll get 2 times square root of 2, which is basically what we have over here. So instead of this you can write 2 times square root of 2. So that's basically that. Now, the next question that we have is basically question number 4, but we are running out of time here in this video at least. So we will continue this in the next video. See you in the next video.